Hello friends, today we'll discuss on recessive epistasis. So it's a phenomenon in which one gene in its recessive stage suppress the expression pattern of other gene, no matter this other gene is present in its dominant or else recessive stage. Suppose these genes are A and B. So if A is present in its totally recessive form, means homozygous recessive form, at this stage it will suppress the expression pattern of capital B or else small b gene. So if we talk about genotypes, then if genotypes pattern are like this, that means A is present in either of its dominant form, then at this stage no matter B is present in its dominant form or else in its homozygous recessive form, so in such type of pattern A is still epistatic over B gene, means A do not suppress the expression patterns of B, either capital B or small b genes. So in such genotype. Now in the second case, if both of the A are present in its recessive form, totally homozygous recessive form, then this small a will suppress the expression pattern of either of the B alleles, that means either capital B or else small b gene. Now if we apply this concept in two parental lines, let's say these parental lines are named P1 and P2 having genotype of capital A, small b, that is responsible for red color flower, and another P2 cell parental line that having a genotype of small a, capital B, that is responsible for white color flower. So all the first filial generation will be capital A small b, small a, capital B small b. So all F1 plants will be purple color flower. Now if F1 will be intercrossed, then capital A, capital B, small b crosses with capital A, small a, capital B, small b, then all the second filial generation phenotypic ratio will be 9:3:4. So that is purple raised to red raised to white flower ratio. So this ratio is slightly different than typical Mendelian ratio, that is 9:3:3:1. Now how come this possible? So I write all the genotypes by putting a Punnett square table. So these are the genotypes in which we can see that A is present in its fully dominant or else in its recessive form or else in its heterozygous form. No matter with A, B is present in its fully dominant form or else its heterozygous form. All the plants will have a purple color flower. So we can find total 1 plus 2 plus 2 plus 4, total 9 plants having a genotype such like that, and these 9 plants will have a purple flower. Now just focus on red color flower formation. In red color, A is present in its fully dominant form or else in its heterozygous form, but with A, B is present only in its totally recessive form, means homozygous recessive form. So at this time A is still hypostatic over B gene. So we can find total 2 plus 1, 3 plants that will have red color flower. Now in the next genotypes, A is here small a, capital B, small a, capital B, small b, or else small a, small b. In these three genotypes, A is present in its homozygous recessive stage. So at this time there are chances that A will not suppress the expression pattern of capital B or else small b. So all the plants having a genotype in which A is present in its totally homozygous recessive form will be white in color. So we get 2 plus 1 plus 3, total 3 plants, total 4 plants will have a white color flower. Now what will be the hierarchy of this conversion? So in the first stage, when white color pigment means there is no color, so at this stage A is present in its totally recessive form, means small a. Now when gene A contains an enzyme A that is responsible for conversion of this white color into red color pigment. So red color again contains, in the presence of enzyme A, contains a genotype capital A, means A is present in its totally dominant form. So with A, no matter B is present either of this capital B or else its small b form, it A will mask the expression pattern of capital B or else small b. So in the presence of enzyme A, that is white color pigment is converting into red color one. Now B gene contains an enzyme B. An enzyme B will convert this red color into purple color. Now again we get A in its dominant form or else in its heterozygous form, and we get another B in its dominant or else heterozygous form. So when A and B both are present in either of its dominant stage or else its heterozygous stage, this red color is converting into purple color pigment. So for the conversion of purple color, both of the alleles should be expressed in either of its fully dominant. So I hope you will understand this concept. Thank you. Have a nice day.